Welcome, grade 11. Let's look at some circles. We're actually going to do some June revision based on circles. If we look at the first one, it comes from the Eastern Cape June 2016 paper. Now, when I approach a circle question, I first scrutinize the question and see what I can gather from what is given. And then I fill everything in on my drawing. So for the first one, it says ABCD is a cyclic quadrilateral. That means all four angles are lying on a circle. So that's ABCD, right? So there's your cyclic quadrilateral. Furthermore, it says that AS is a tangent. So let's just run through a tangent. So AS is a tangent. So please remember, with a tangent, you look at a triangle inside a circle. Then this angle lying between the tangent and the chord, this is a chord. Everything that's not a diameter is a chord. So this angle between the tangent and the chord will be equal to not to this angle attached to the chord, but to the opposite interior angle. Right. Keep that in mind. It also says here that AD is parallel to SC. So this line is parallel to SC. So it means it's also parallel from there to there. Parallel, so we think alternate, we think corresponding and co-interior. Furthermore, the last one, AD is equal to BD. So then we think of angles opposite equal sides. Now, the first question says, name with reasons 5 other angles, each equal to x. Now, if I start off with my angles opposite equal sides, which I want to start off with, it doesn't mean that it will be wrong if you don't start with it. So you maybe can start off with alternate angles. Can you see there? That will be alternate angles. So it depends wherever you want to start off. But try to start off with the x, because I mean, that's the only given one that you have is a 2. So I'm going to start off saying that angle B2 is actually going to be equal to A2 because it's angles opposite equal sides. Angle B2 is equal to A2 is equal to x. Angles opposite equal sides. Sometimes when I went past pupils' desks and I would see what are they doing and how do they fill in everything, sometimes I would see, but there's nothing on the drawing because some, pupils don't want to scribble on the drawings. Then I'm normally sort of in shock and I would say, listen, I would suggest you grab a pencil. With color pens, you can't erase it, but with a pencil, at least you can erase it. So grab a pencil and start off with little pictures. Of course, color looks so much better. So if you do have an erasable color pen, then use color. So we must find 5 other angles equal to x. So I've got this one. Now I'm actually just going to work with my angles, alternate angles. Can you see there and there? Again, you can start off at any place. If I again work with A2, I prefer always just to write it the same angles underneath, underneath each other. The angle A2 forms Z is equal to B3. That's equal to X. Alternate angles, and you must mention AD is parallel to SC. Right, so we've got that one. Let's see what else. We can also say, Okay, I'm still looking. Oh, I see I've got my cyclic quad. So it looks like this. Now, analyzing a cyclic quadrilateral to see what we can work with, you can extend a leg. I just want to show you again, how does the exterior angle of a cyclic quad work? So if I have a straight line being extended, it can be that line, anything, then let's look at the exterior angle of a cyclic quad. So this angle there will be equal, not to this line and this line. So I sort of draw a picture for myself. It won't be equal to the angle attached to this line or the angle attached to this line, but it will be equal to that on the opposite interior. Think of a kite. Think of the tail of the kite here. That's the bottom two pieces, and that is, the angle where it will be equal to. So looking at that, let's quickly get some color. Can you see with the cyclic quad, if you extend this leg and you look at this X, think of the tail now of your kite. This is the bottom section, so it will be equal to D1 plus 2. This was just a mistake. So that one will also be equal to X. I'm going to say angle B3 is equal to angle D1 plus 2, or you can refer to it as A DC. My reason is going to be exterior angle of a cyclic quad. What haven't we used yet? We haven't made use of a tangent. So because AS is a tangent, let's see which one will be equal to which one, which possible one. Well, if you look at this triangle, then that X will be equal to A1. Let's make sure you see it. This angle between the tangent and this chord will be equal not to this line attached to the angle, meaning it won't be equal to D1 attached to A1. It won't be equal to this one. But if you look at your triangle, it will be equal to the one furthest from the A1. So we can say A1 will be equal to B2. And the reason is tan chord. Tan chord. So now we have 4, we need a 5th one. Sometimes it's a good idea to redraw everything, and not sometimes, often. It's actually what I suggest you do, that you pause the recording and you try and fill in everything. And if there's anything that I explained that you don't understand, take a picture of it, leave a voice message and WhatsApp me. So the last one here that we're going to work with is the corresponding angles, the F. So there's your line and there's your line. So this one attached to the parallel line here, I always like to work with arrows. This one is equal to that one. Angle A1 is equal to angle S1 is equal to X. Corresponding angles AD is parallel to BC. All right. Now for the next question, it says that we must prove that ASCD is a parallelogram. So in order to do that, we need to know what do we need to prove? What are the different methods of proving a parallelogram? Sorry, this was an error on my slide. So what I'm going to do, I'm first just going to fill in everything again. That was the X. This one was a X. This was a X. This one was a X. There's a X. And there's a X. Then I'm going to check where's my parallelogram. AS. There. AS. CD. There's your parallelogram. And this side is parallel to this one. Let's quickly run through the different ways of proving a parallelogram. If you can prove two pairs of opposite sides are equal, is that possible with this black diagram? No. We only have DA, so there's no way that I can prove CS is also equal, let alone the other two. One side is equal and parallel. One side is equal. Well, I don't even have it that it's equal, but I do have that it's parallel. Two pairs of opposite sides are parallel. I am going to investigate this option because I already have one pair of sides which are parallel. Diagonals bisect each other, meaning these two pieces will be equal and these two pieces will be equal. Well, I don't have even a midpoint here. So I don't have two diagonals. I don't even have one diagonal, so I won't be able to use that. But do you see how you analyze which option you're going to investigate? This one, diagonals bisect each other. Now that's the one I did there. Sorry, I was not focusing. The last one here would be opposite angles are equal. Just get the pen back. Opposite angles are equal. Well, we have one opposite angle. We have D1 and D2 is equal to S1. That we have. But I can't prove that C is equal to A2 plus 3. So there we have a bit of a problem. So what else can we look at? Well, we have AD. AD is parallel to BS. Let's name it CS. Okay, that was given. So now try and think, is it possible maybe to prove that DC is parallel to AS? Because if it's possible, then we are sorted. So let's see if it is possible. Can I somehow prove that DC is parallel to AS? Now, in order to prove that, what do we need? We need to try and see if we don't have a corresponding angle, right? What do you think? I have A1, right, is equal to D1 plus 2. Do you see this? So what does that mean? It means that angle and this angle is equal. And can you see it forms a Z? It's not so easy to see. You see? So that's why I say I work with arrows and it's sort of easier to see it. So that one is your parallel and this one. So it's actually forms alternate angles. Therefore, this side is parallel to that side. quickly write it down. So I can say A1, angle A1 is equal to angle D1 plus 2, or again, you can just refer to it as angle ADC. That's given. Well, it's actually proven, it's not given. It's proven because we proved it in the previous slide. So it's proven. Then you can say, therefore, DC will be parallel to AS. Converse means the opposite. So I'm just going to say it's converse of alternate angles, meaning because it's alternate angles, therefore the sides will be parallel. Or you can just write here alternate angles. Because it forms alternate angles, therefore the sides will be parallel. And there you have it. So we actually made use of this one. So now we're in, therefore, ASCD is a parallelogram. If you don't know all of these reasons, then please go slowly through the recording and listen to all the reasons that I gave you and just write it down somewhere. You know, have a summary file. ASCD is a parallelogram, and the reason will be two pairs of sides are parallel. Right. For the next one, we need to say, name a triangle that's similar to triangle ADB. Now, in order to do that, we first need to understand similarity. So with similarity, it's when you are similar to dad or mom. Not exactly the same, you're just similar. So it means you have the same characteristics. And what is the requirement for two triangles to be similar? You need to have two angles. Need to have two angles. So if two angles are equal, the third one will always be equal because of interior angles of a triangle. For example, if this one is 10 degrees and this one is 10 degrees, let's say this one is 80 degrees and this one is 80. So 80 plus 10 is 90. Therefore, this one can only be equal to 90 because of interior angles of a triangle. Now let's see, before we can look for similar triangles, we need to fill in the X again. You know, all the angles. And that one. Right, let's see. So we must prove a triangle similar to triangle ADB. So what I'm going to do is I'm first going to look, where's ADB? ADB. Can you see that angle A is an X? Angle D is this one. So I'm just going to indicate it with a dot. ADB. It's an unknown one, so I'm just indicated with a dot. And the B again is an X. So if I can find any triangle that gives me this scenario, then I know it's going to be similar triangles. Let's see, where can I have an X and another X and an unknown angle? Well, in this triangle, here, DC. B, I can't because the whole of D1 plus D2 is X. But I see it here. So if I can name it, you can start anywhere. Yeah, you can start off with S going to A. I'm just going to name it as B going towards the unknown one, and then going to S. So I can look at B, angle A3, well, this would be B3, angle A3, and S1. So that one is a X, this one is a dot, and that one is a X. So therefore it will be similar. So, but you can't just write it like that, right? Well, it's one mark, so you don't have to prove it. So we can just say, name a triangle. So triangle BAS will be similar to triangle ADB. Then this one, I see this magic word hence. Hence always means that you must make use of the information in the previous question. That's what hence means. Just want to fill in everything again. We really can't solve anything if we don't fill in what we just proved. That one was also an X. Right. So now I like to start off with what I just proved in the previous one. So in the previous one, I will just say here, I didn't write it here. Let's just add that just to play it safe. Therefore, triangle ADB will be similar to triangle BAS. So now I'm going to work with what we just proved there. So I'm going to say triangle ADB is similar to triangle BAS. That was proven. Then in order to do stuff like this, I like to keep an eye on what I need to prove. I'm writing very big, so I'll write it here. SC times SB, I need to prove is equal to DC squared. So I'm going to write it as DC times DC. Then I also like to write it as a fraction, you know, as a ratio. So DC, you just pop it down here. And in order to get back to this one, when you cross multiply, it means your DC must either be, you know, at the top or the bottom. SB. So if you cross multiply this again, you'll get back to this one. So I'm just working backwards to see what I need to work with. So this is what I have, and this is what I want. So because these triangles are similar, we can say, therefore, AD on top of BA will be equal to DB or BD over AS. That will be equal to the whole of AB over BS. Reason, similar triangles. So let's see, what can we substitute with what? Let's look at BD, right? I've got a BD here. There's a BD. And BD, if you analyze it here, it's equal to AD. Right? Is that going to help me? No. Let's see what else. BD. I also have AB here, which will be equal to AS because it's, angles opposite equal sides. So I've got an AB. There I've got an AB, which I can substitute for AS. Okay. Let's see. I'm also still just quickly looking what we can substitute with. So SC, yeah, we can work with this one as well. Can you see this whole, because we proved it's parallelogram. So this whole of AD is also going to be equal to SC. Okay, now I'm getting there. So this SC, I can try and sub with AD. So I'm going to say AD is equal to SC. Opposite sides of parallelogram. So instead of writing AD, I'm going to write SC. So then at least I have 1 over BA or AB. Okay, the rest I just rewrote everything. What can we do maybe with AB? AB is equal to AS. AB is equal to AS. But that's not really going to help me. Yeah, I don't have an AS. Let's see BS. If I just, change this, as SB is actually the same as BS that I already have there. So let's cut out the middle section. You see how you play around. So let's just work in alphabetical order. BA we can write as AB equal to AB over SB, because BS and SB is the same thing. So now, what else? I sit here with the AB and I would like to have it as a DC. AB, I would like to have it as CD. CD. AB. Can I? Yes, I can. Because AB is equal to AS. That was proven because these two, angles are equal, or you can just write, angles, no, not angles, sides, opposite, equal angles. Now, we haven't really proved it yet, have we? I'm going to erase that. We haven't really proved it yet. Okay, so it's sides, opposite, equal angles. Do you see what I'm doing? I'm working with the reverse. We normally say angles opposite equal sides. If we have the sides, then we say, okay, so this one will be equal to this one. Angles opposite equal sides. But now it's the opposite. We sit with angles that we have that are equal, and therefore we can derive. If I work with dotted lines, it's when we say therefore, So this one would be sides, opposite, equal angles. So the given is always written at the end, the given. Okay, so AB is equal to AS, sides opposite equal angles. AB is equal to AS, and AS, you see again, I'm writing it underneath each other if I repeat something. AS is also equal to DC. Why? Because it's the opposite sides of a parallelogram. So now it means I can substitute my AB with a DC. So instead of writing AB, I can write DC. So SC over DC is equal to DC over SB, and then you just cross multiply. So therefore, SC times SB will be equal to DC squared. Yes, so this is not always easy. You see, even I started off here, I wondered which one can I sub with which one, but that's how you approach it. And you just write out what you have to prove, and you keep an eye, on what you have and where you have to go to, and see what you can maybe cancel out with what or substitute with what. Here's the next one. Again, I suggest you pause the recording and that you quickly write down the questions. And then you first try by yourself. Why do I say that? Because it gives you self-confidence. Okay, let's look at the first one. Okay, again, there's a few funny things on my drawings. In this diagram, let's analyze what's given. O is the center of the circle, right? So if O is the center of the circle, there's already a few things that jumps to my mind here. Center circle, so I know I sit with equal radii. So those two sides are equal, therefore this angle will be equal to that one. I also immediately think of center angle in the center of the chord will be equal to twice the angle on the circumference. So if this one is 4x, this one will be 2x. So that's immediately what's jumping into my mind. Then there's a few sides that's given that are equal. Okay, let's analyze. So if you see the center of the circle, you quickly do your radii indicated. ABCD is a cyclic quad, A, B, C, D. So I'm thinking of angles in the same circle segment, but I don't have any. But I can possibly keep in mind, I can't work with the diameter, but I can think of my exterior angle of a cyclic quad. Then it just says that AB is equal to that, right? Determine in terms of x, angle B2. B2, so there's B2. And they say in terms of x, it means you won't get an exact answer. So I'm going to start off here saying that angle B2 will be equal to angle C3. See, these two will be equal because it's angles opposite equal sides. I personally like working with variables when I prove stuff. So I'm just going to say let B2 be equal to C3 will be equal to Y. I said let it be. So then I'm just going to work with my interior angles of a triangle. So therefore, 4x plus y will be equal to 180 degrees. Y, interior angles of a triangle. So 4x is going to be equal to 180 degrees minus 2y. And I want to get the 2y alone, actually. I want the 2y alone, right? So I will rather just do this. Not going to help me to get the x alone. It's going to be minus 4x and divide by 2. So now I've got a value for y. So therefore, the y value, and the y value is actually b2. So this one will be 90 degrees minus 2x, as well as this one. So therefore, b2 will be equal to 90 degrees minus 2x. You see, in terms of x. Okay, again, try and pause the recording and try this one, E. So before we can look at E, I'm just going to fill in what we just worked out. So we just worked out this one, 90 degrees minus 2x. The others I explained to you, but we haven't done it yet. Work out angle E. Now let's look at the big picture here. If you look at the big picture, it seems that this line and that line is equal. So it means this angle will be equal to this angle. If I analyze this, is there any way that you can actually do something about A1 and 2? Because I need to, because I mean, this is all I have. I have that these angles are equal. Well, if I work with my 4x, that one will be 2x, and then I can work with my exterior angle of a triangle. Okay, let me show you. So I'm firstly going to say that you can either say angle O is equal to 2 times angle A3, if you want to, or you can, okay, let's just write here, angle center circle equal to 2 times the angle at the circumference. So angle O equal to 2 times 2x, 2 times angle A3. Sorry, I'm messing up. And angle O is actually a 4x. It's equal to 2 times angle A3, so you just divide by 2. Or you can actually say angle A3 is equal to half of angle O. So that's half of 4x. That's 2x. Right. Now that we have A3 is 2x, it's that one. The exterior angle of a triangle is equal to the sum of the opposite interior angles. So now I'm going to say that angle E is actually equal to angle C1. It's angles opposite equal sides. So then I'm going to do the same trick as in the previous slide. I'm just going to say, let angle E be equal to angle C1 be equal to Y. And then I'm going to say 2x is equal to angle, well, let's be, yeah, is equal to Y plus Y. But let's be decent here and say that A3 is actually going to be equal to angle E plus angle C1, and give the reason. Exterior angle of triangle is equal to 2 times the opposite interior angles. It's equal to the sum of the opposite interior angles. Got it. So 2x is equal to 2y divided by 2, so x is equal to y. You don't have to do it in such a long manner, actually. You can, do the shortcut. You don't always have to prove and work with that with a y and a x equal to the sum of the opposite interior angles. Got it. So what do we have here? We have x is equal to y, so it means angle E is going to be an x and C1 is going to be an x as well. So therefore, we can write angle E as an x. Therefore, angle E is equal to x. Next one, you must figure out C2. So from today's lesson, what can you take from this? You scrutinize the question, you fill in everything from the question, and I taught you how to work with exterior angles where you just let something be equal to x, not x, but something like y, because I already worked with x's. You can say let it be equal to k, it doesn't matter. And you also learned that you must fill in everything on the drawing as you work. Okay, we're nearly done. Let's quickly try this one. And what have we filled in? This one we've done, that's an x, and this is an x, right? It says now determine in terms of x angle C2. So it means this unknown one we must work with, this one. So let's make it a squiggle and a squiggle. So if I must work out this one and this one, what jumps to your inside your head here? Well, the fact that I can work with interior angles of a triangle. So I'm first going to say that this whole angle is equal to that one. Angle B1 plus B2 is actually equal to angle C2 plus C3. The reason? Angles opposite equal sides. So now because 90 minus 2x is equal to 90 minus 2x, therefore C2 must be equal to B1. So therefore angle C2 will be equal to B1 because the whole angles are equal. And then again, I'm going to work with my y. So I'm going to say let angle C2 be equal to angle B1 be equal to y. And then it's just plain interior angles of a triangle. So A3 plus C2 plus C3 plus B1 plus B2 will be equal to 180 degrees. Just put this angle thingy there. Why will it be equal? Interior angles of a triangle. Now let's fill in. A3 was 2x. C2 is a squiggle, so we made it a y. C3 is 90 degrees minus 2x. B1 is a y, and B2 is 90 degrees minus 2x. 90 plus 90 is 180, and there's a 180, so that will fall away. 2x minus 2x will be gone. So we only sit there with a minus 2x is equal to 0, and there's a y plus y, which is 2y. And just divide by 2, so y is equal to x. Y is equal to x, and we said we made C2 equal to B1, so therefore C2 is equal to x. Seems we only have x's and 2x's. So that one is an x and that one is an x, right? Hope you've got that one. Then this one. this would be the last question for this session. If E is equal to C2 is equal to X, you see now at least we can be quite relieved because now they basically tell us that we were right. Then it says, prove that ED is a diameter. So I'll show you now when is something a diameter. I'm just filling in everything that we already worked out. This one was 90 degrees minus 2x. This was the x. This was 90 minus 2x, and that was the x. Now, when is something a diameter? Something is going to be a diameter if it subtends a 90-degree angle, meaning if it lies underneath a 90-degree, it will be a diameter. So I like to see what must I try and prove. Prove that ED, so let's see where's ED. There's ED. Prove that it's a diameter. So when will it be a diameter? Well, if we can somehow prove that angle A1 is 90 degrees, right? So that's what we're going to try. I always work with dotted lines to indicate what we must try and prove. So let's see, how can we try and prove that one is 90 degrees? Well, if we can somehow get hold of more values here, then we can. So let's see. Well, what can I say maybe about D2? Can you see there's a line coming out? So I can say that angle D2, I'm just randomly saying something. D2 will be equal to, think of the kite, because it's cyclic quadrilateral. So that's the bottom section of your kite, and this is the tail of the kite, can you see? So the top section of your kite will be that part and this part. So exterior angle of a triangle means D2 will be equal to angle B1 plus B2. That's equal to x plus 90 degrees minus 2x. Reason, exterior angle of a cyclic quad. And that then will be equal to 90 degrees minus x. And let's fill it in. So D2 will be equal to 90 degrees minus x. Then I'm going to work with my interior angles of a triangle here in this triangle. So I'm going to say angle E plus angle A1 plus angle D2 is equal to 180 degrees. Reason, interior angles of a triangle. Angle E is a x. Angle A1 we don't have. D2 is 90 degrees minus x is equal to 180 degrees. So angle A1, therefore, will be equal to 180 minus 90, which is 90, and the x's will cancel out. So therefore, ED is a diameter. I always like just to say converse, meaning the opposite, converse of angle in semicircle. They'd also accept if you just say angle in semicircle. But I prefer to add the word converse because we don't know this is a circle. We had to prove ED is a diameter. So preferably work with that. Converse, meaning the opposite of angle in a semicircle, means that it will be a diameter. Thanks for joining, and hope circles makes a little bit more sense.